Should we start? Alka Nishant, should we start?
Okay, ma'am. Yes, ma'am.
Okay. Actually, I'm outside of my campus, so maybe there will be some network problem, but we will try to manage it. So this is week 7, and I'm Jyoti Sharma, and I will be taking this class. This is my brief introduction. I'm just repeating it. I'm a PhD student from ISER Bhopal, and I had my MSc from Forest Research Institute, Dehradun, and PhD from University of Delhi. And because it is my responsibility to teach 50 hours per year, so I'm taking class on online on NPTEL. So let's start. As usual, there will be a discussion. You are free to speak whenever you want to, and you can raise your question. You will discuss anything related to the subject matter, and your participation is highly valued. So I have lots of MCQ question, and we will try to solve it. And this week mostly covers 5 lectures, and these 5 lectures are related to emission inventory, in which there is a case study. I will try to cover it as well. Then there are some method of source apportionment, so we will try to learn what do you mean by this source apportionment, and then how we can measure it using receptor modeling, and some brief introduction about the air quality, indoor air quality, and some specific source and type of air quality pollutant. So let's start with first question, and this first question is related to the source apportionment. So what do you mean by this? So I have 4 options. The first option is it is a pollution level at receptor. The second option is it is the contribution of pollution generated by the emission origin. Third option is it means pollution in the atmosphere. And fourth is it means the contribution of pollution generated by receptor itself. So what should be the answer? So this is basically the definition of the source apportionment. So you can guess and you can write in the chat box whatever answer you are thinking that it is right. This is related to the definition of the source apportionment. What do you mean by source apportionment?
Is it B or D, ma'am?
Okay, so you have to tell me what's the difference between B and D, and which one you think that it is the right answer. Like there is a difference between emission origin and the receptor. So like what should be the answer? Like I will explain it obviously. Either it should be from the emission origin or from the receptor itself.
I think B, ma'am.
Okay, Alka, what do you think? Alka, will your response?
Yes,
What should be the answer? Like, what do you think? What do you mean by source apportionment? Is it A, B, C, or D? What do you think?
maybe receptor tane.
Okay, so the right answer is B. And this means nothing. Like, if you will see the dictionary meaning of source apportionment, then it means divide up and share out. It means it is the contribution of a source. For example, if there is a factory and that factory is related to the iron, okay, so and you have some atmospheric pollution in the atmosphere. So how much pollution your that iron related company is contributing? So this is the source apportionment. I show you. Okay, so here you can see like I have two pie chart. The one is related to particulate matter 2.5 and second is particulate matter 10. So here we can decide what's the contribution of the transport, what's the contribution of industrial areas, what's the contribution of biomass. Like this is the these all are the source. Okay, so the source transport. So what's the contribution of that to the concentration of particulate matter 10 in our atmosphere? So this is the source apportionment. So this is nothing. I have definition of it as well. So this is the practice of deriving information about pollution sources. So after all, after some methods, you are getting the information regarding from where the pollution is emitting. Okay, and the amount they contribute to ambient air pollution level. So this is just nothing you have to keep in mind. You want to get the information about the source from where the pollution is emitting. And for example, in Delhi, sorry, let's say we are taking the example of Noida, okay, and we are assuming that Noida doesn't have any kind of companies or industries, but the pollution is coming from the Delhi area. So how and there is some level of pollution in the Noida. So how will you know? How will you get to know like from where this pollution is coming? So you need some kind of model, you need some kind of approaches by which you will calculate. And this is very important, from where the pollution is coming out. Because, for example, let me show you. Yeah. So here you can see the most portion from where this particulate matter is coming is the industrial area. So if we formulate some kind of policies related to the industries, then we can control our particulate matter in a very huge amount. So that's why this is very important to have the information about the source and how much the source is contributing to the air pollution. So that's why this is a practice of deriving information about the pollution source and the amount they contribute to ambient air pollution level. I think this is clear. What do you mean by this source apportionment? Okay, so this question is related to why do we need to have the source apportionment? Means what is the need of calculating the contribution of the source? So I have four statements. The first is it can improve existing air quality management system. The second is it can act as the first step to begin an air quality management system. Third is it can help in prioritizing the emission source control, and fourth is it can help in determining the noise in the atmosphere. So why what's the importance of this source apportionment? So this question is related to that only. So what do you think, what should be the right answer? A, B, C, D. Okay. Yeah, here it is only A, B, C, but it is A, B, C, D. By mistake it was happened. So you can tell me accordingly from A, B, C, D. Like what's the importance of calculating how much that company, how much that transport is giving you the pollution? So what's the need of that?
1, 2, and 3, ma'am.
1, 2, 3. Okay, Alka, can you guess?
One and four.
1 and 4. The fourth
No,
option is
1, 2, 3. Sorry.
yes, 1, 2, 3 should be the right answer, because the first thing, it will improve the existing air quality management system. So for example, uh, let's say one example is it like you have some kind of policies, and based on that policies, you know that particulate matter 2 is more emitted from, let's say, industries. So we can formulate the policy, the first thing. The second thing is there may be some instrument that are that can help in filter out the air, and that can we can capture the air pollutant particulate matter using that instrument. So we can also improve our instrument based on that, based on the importance of that gas and based on the importance of from what industries it is coming. So for example, if it is a company related to mining, okay, so first you will got to know that this is the chemical that is most being related by that company. So you can impose some kind of directions that you must have to install this type of instrument, the instrument that can control, let's say, sulfur dioxide, if sulfur dioxide is being emitted by that particular company or industries. Okay, so that's why it can improve your existing air quality management system. The second is just like the first one, it will be act as a first step to begin an air quality management system. And third is it helps in prioritizing the emission control, emission source control. So for example, again, we people know that most of the carbon monoxide and nitrogen dioxide, or nitrogen oxide, has been emitted by the vehicular. Okay, so most of the policies you can formulate for the vehicular emissions, because you know that the most of the contribution for this carbon monoxide and nitrogen oxide is from the transportation. So likewise, you can such kind of information will help you in prioritizing the emission source control. And fourth is nothing, this like help in determining the noise in the atmosphere. Like there is no any relation of noise to the source apportionment. So answer A, B, C. So B should be right answer. And it's somehow like, so 1, 2, 3 is the right answer. Okay, so this was the importance of the source apportionment. Now, we also have, like, there is not much difference between the importance and the significance, but my third question is related to the significance of the source apportionment. So it quantifies the pollution arising from. So you have to tell me how it is quantifying the pollution. So from regional source, long distance, long range transport, transboundary transport, and not natural sources. So what should be the right answer?
All.
Okay, any guesses?
All.
Okay, yes. Okay, so answer should be the all. Why I tell you, for example, I gave you the example of like there are some industries in the Delhi, and but your receptor from where you are sensing the air pollution is in Noida. Okay, so from where this pollution come from. So you have to see what are the regional sources. Then you also have to see either your pollutant has been transferred from one position to another position. You have to see whether your pollutant have transported uh, to the different boundary, and then it may be from the natural sources. So and whenever you are doing, like whenever you are calculating the contribution, then of course you need some kind of dispersion model. If you people read about that Gaussian model, so Gaussian model is doing nothing, but whenever there is a pollution out of the chimney, then it is estimating in what direction, at what distance pollution will be dispersed. Okay, and this is based on the meteorological condition, this is based on the lapse rate of the environment, and so such type of transport will be calculated using that. Yes, Mohammed, you want to ask some question? Okay, anyway, so D should be the right answer. Here you can see, like, your pollution can transport from one position to the another position. So you have to consider such kind of transportation of your pollutant whenever you are calculating the source apportionment. Okay, so we have different type of approaches to calculate this source apportionment. So you have to tell me what different approaches we have to calculate it. And options are top-down approach, the bottom-up approach, top-up approach, bottom-down approach, and you have to select the option. So what should be the right answer? What are different approaches we have?
1 and 2.
1 and 2. Any other guesses? Alka gave me answer A, 1 and 2. Okay. Anyone else want to give the answer? Okay, so obviously answer should be A. So we do have two approaches. Uh, the first is bottom up or second is top down. So bottom is also known as the source based because we will start this kind of approach from source only. Then the second we have the top down, and that is also known as the receptor based method. So here this from like the initial step will be from the receptor, so we will know this what do you mean by these two kind of approaches. So this is a very like this is not related to the environment science example, but yes, this is the example by which you can understand. So whenever you want to uh, like bottom up approaches, firstly you will go to the company, then from that company you will get some kind of data. Based on that type of companies, type of the monetary value each company is contributing to the economy, you will divide it into some sectors based on their work. Then you will, after dividing into sector, you will calculate how much economy of your country have based on the companies. Okay, so this is the bottom up approach. You are getting the information of company first, then you are divided into some sectors, and then you are calculating your economy. This is the bottom up approach. But the top down approach is you have some GDP, like you have the economy. Based on that GDP or the economy, you will try to find out the contribution of each company. Okay, so this is the bottom up approach. You already have the GDP value and you want to calculate from which company you had what contribution. So this is the top down approach. Uh, so if we take the example of environment, then bottom up means you will first create the emission inventory. Emission inventory means each company, each industries, each activity, how much it is contributing to the air pollution. So for example, like not contributing to the air pollution. For example, you have a coal industry, okay, and you know that coal industry will lead to the production of mercury as well as the sulfur dioxide. Okay, so how much sulfur dioxide it is releasing into the atmosphere? So this is the calculation of the emission inventory. It doesn't mean that at 10-kilometer distance, because you want to calculate at that point at 10-kilometer uh, uh, distance what level of sulfur dioxide you will get. So this is different to that. Just keep in mind how much your industry is releasing, how much vehicular emission is releasing, and the releasing amount will be different from the concentration that you have in the atmosphere, because there may be some reaction, because atmosphere itself has some cleansing mechanisms. So the concentration in the atmosphere will be different from what has been emitted from the different industries. Okay, so by emission inventory you are just calculating how much pollution, let's say carbon monoxide, let's say nitrogen dioxide, it is releasing into the atmosphere. So so you will create the emission inventory. Then based on the quantity of that pollutant, you will put this as a input in the source model or the dispersion model that will disperse this pollutant into the atmosphere, and then you will estimate the exact concentration in the atmosphere you have of that particular pollutant. So this is the bottom up approach. The second approach is top down. So top down means you will like if you have this air quality index, so based on that air quality index or based on some satellite data, you know that this much air pollution we have in the atmosphere. So for example, in Delhi there is air pollution, like the value of AQI is more than 300 microgram, or like this is the scale, then let's say it's 300. Okay, so in the top down you first have the pollution level in the atmosphere. Then from that you want to calculate how much different industries are contributed to that uh, pollution. Okay, so how will you calculate? So this will be based on what type of pollutant you have in the atmosphere. You will have to do some kind of chemical analysis. For example, if there is a particulate matter in your atmosphere, then you will go to the laboratory, you will collect some samples, and you will see what is the characteristics feature of that particular matter at that particular space, a particular area. And based on that, for example, this particulate matter have a high quantity of sulfur dioxide, okay, or the sulfur content, then you can estimate like this must be come from the coal company or the coal industries. So based on some model you will calculate from atmosphere to source. So this is the top down approach. And because last 1 week we talked about emission modeling, or the dispersion modeling or the source modeling. After creating this emission inventory, we talked a lot about this emission inventory, but right now we will focus on the receptor model. How from the pollution you have in the atmosphere you will decide the contribution of the source. So top down approach. um, Okay, first, there is something about the bottom-up approach. So in that bottom-up approach, you will identify the emission activities or the pollution source and their emission strength. So for example, if you went to the thermal power plant, then you will see if there is a coal burning, then how much sulfur dioxide is being releasing from that thermal power plant. So you will see the activities, what activities is there in that thermal power plant. There may be combustion, there may be like some transportation of the vehicle within that area. So firstly you will list out the emission activities, then you will see the sources, and then you will see the strength of that emission. Then you will convert it into the emission factors. Emission factors means whenever you are doing the combustion for let's say 1 hour, so how much of the carbon dioxide will be released into the atmosphere. This is the one example. So if you are doing the combustion, how much nitrogen dioxide will be releasing into the atmosphere. So you are calculating this conversion factor. Then you will multiply it. Then there will be dispersion model, as I told, such like the Gaussian model, that will give you the movement of that pollutant from that source, and then it will give you the concentration of the pollution into your atmosphere. So this is the bottom up approach. Okay, so as I told you, different steps of the bottom approaches. I also show you once again. So this is the bottom up approach. First you will create the emission inventory, then the input of that emission inventory will go to this source model or the dispersion model, and then you will calculate the estimated ambient concentration. And my question is related to the what is the right sequence of steps in bottom approach. So these are 5 different steps, and you have to tell me what should be the right sequence of the steps. What should be the first step, then what should be the last steps. Based on that you can tell me. So options are documentation of primary pollutant and secondary pollutant, identification of the potential source, baseline mapping of the pollution and hotspot, description of the physical and chemical processes, apportionment of the pollution by source. What should be the sequence of it? You people can take time and tell me. Alka gave me answer B. Okay.
B, ma'am.
Okay. Anyone? Okay, so answer is B, and yes. So B means first, what will you do? First, you will identify the potential sources. Okay, means you will identify what can be the potential source. It can be the vehicular emission, it can be the thermal power plant, it can be mining industries, it can be mining itself, it can be like the pharmaceutical companies. So first you will identify the different potential sources. After this, what you will do, you will have the description of the physical and chemical processes. Why physical and chemical processes? Because these physical and chemical processes of your pollutant will decide how they will move into the atmosphere. Okay, so this will be the second step. The third will be you will do the documentation of primary pollutant and the secondary pollutant. And obviously you have to see how much pollutant you are releasing into the atmosphere. So there may be primary pollutant and there may be secondary pollutant. Then you will create the baseline and then you will calculate the apportionment. So I have step by step so that you can have a good knowledge about this. So the first is the identification of the potential source. So this is identification of potential source physically and quantitatively, energy uses and the emission strength in the city or the region, and it is required for the preparation of the emission inventories. If it is a second step, that is the description of the physical and the chemical processes, then there must be the description of physical and chemical processes with respect to the potential to impact the advection. Advection means the horizontal movement of the pollutant and the chemistry of the pollutant. Okay, because you should have such kind of knowledge, and if you doesn't have such kind of knowledge, then you can't calculate how this will be moved into your atmosphere. So you should have the description of the physical as well as the chemical processes, and it also include the local topography, because whenever you are talking about the movement of your pollutant from one place to another place, then topography will play a very important role. If it is a terrain, if it is a mountainous terrain, if it is a like plain area, every time the movement will vary. So that's why you have to consider this local topography as well. Then meteorological feature, for example wind, for example the temperature, humidity. Based on that your movement will be determined. Then, and this is required for the dispersion modeling, as I told you, for example the Gaussian modeling. So these all things are required for the dispersion modeling. Then third step was documentation of primary pollutant and the secondary pollutant. So what do you mean by primary pollutant and secondary pollutant? Have you cleared about this, or should I explain this? Alka, do you know what's the difference between primary pollutant and secondary?
इसके एग्जाम्पल पता था.
Okay, so like primary pollutant is nothing but this is emitted from the emission sources. For example, there is a motorcycle and motorcycle is releasing the uh, carbon monoxide, or let's say carbon dioxide. So these are the primary pollutant, means directly emitted into the atmosphere from the emission source. And if we talk about this secondary pollutant, so we had the primary pollutant in our environment. That primary pollutant will react with the different primary pollutant, or it may react itself. It may react in the absence of sunlight. So after some reaction in the atmosphere, it will create the secondary pollutant. For example, you have carbon monoxide. Let's say you have nitrogen oxide. as a primary pollutant because this has been released by your motorcycle. Then in the presence of sunlight, this will give you oxygen, and then this oxygen will react with another oxygen, and that will create the ozone, tropospheric ozone. So this ozone is nothing but the secondary pollutant. Okay, so this is the primary and secondary pollutant. And you people know about the primary pollutant, like from any vehicular emission or from the industries, you can easily calculate how much primary pollutant you are emitting from that source. But it is very different to calculate the secondary pollutant because this is formed by the reaction among this primary pollutant itself, and this is reaction happens in the atmosphere. So how will you calculate this secondary pollutant? So we need some models. We will give the input of primary pollutant, then this such kind of models will give you the concentration of the secondary pollutant. Okay, so such like there is a one example, the chemical transport model. So such model will give you the quantification of the secondary pollutant, such as these are the example of the secondary pollutant: sulfate, nitrates, ozone, hydrocarbons, etc. Here you can see like this is the primary pollutant and secondary pollutant. So directly emitted from some sources, this will give you the primary pollutant. They will react itself, they maybe react with another species into the atmosphere, then they will form some different compounds, and these compounds will be known as the secondary pollutants. And these secondary pollutants can only be estimated using some models. Okay, so this was the third step. The fourth step is baseline mapping of the pollution and the hotspot. So what will you do? Because you have the input data, you have the information of how much primary pollutant the industry is emitting and how much secondary pollutant the industry is emitting. Then you will put this value into another model, for example dispersion model, Gaussian model, and that will give you the value at some receptor, like 1 kilometer away from the source, how much concentration you will get. So such type of model will give you the pollution concentration at the point of the interest. Okay, and we have some source model or the dispersion model to calculate these. We already have talked in last lecture. These are like there are lots of model, and two important are Gaussian plume model and the Lagrangian model. Okay, and then there are some advantages and disadvantages of this bottom-up approach. So what are the advantages? Advantages are locating pollution source through the development of emission inventory. So first we are creating the emission inventory, then we are locating the pollution source. Okay, the second advantage is it can identify potential sources of primary emissions. Okay, you know about the primary pollutants, so it can identify the potential source. Then it can also describe the relevant physical characteristics that affect the ambient level. So because we need meteorological condition, we need topographical information, and this will also be considered into such kind of models. So this is very relevant for us. Then understanding the chemical processes that influence local pollutant level, including the formation of the secondary aerosols. So as we told, after getting the information about the primary pollutant, we will feed this information into some chemical models that will give us the information how much secondary pollutant are being forming by that. So such kind of information also we will get. Then documenting the potential for secondary aerosol formation, we already have talked about this. Then identifying the sources that would be most effective in controlling and affecting the ambient compliance level the most. So by this you can identify which source is very dangerous in the means of the higher level of pollution it is releasing. So based on that you can pinpoint that kind of source so that there may be some policies that can prevent that kind of pollution. Then allowing for a direct estimate of the estimate for the effect of changes in emission on ambient pollutant concentration through emission control simulation. This is again the, like we already have discussed. Then providing spatial coverage of how source impact air quality and exposure. So you will get a spatial map where are the sources and how much that sources are contributing to your air pollution in that nearby areas. So such type of information, everything you will get from this bottom up approach. But there are also some disadvantages of the disadvantages is because you are calculating the emission factor. Okay, so and to calculate this emission factor, there is a huge requirement of the laboratory. So you must have the laboratory facilities for that. The second is like you have all type of datas. So like your team should be very big. Each companies in each company, each activity, for each activity you will calculate how much different pollutant it is releasing. Then if you want to calculate it for, let's say, 100 kg of pollutant, then how much, sorry, 100 kg of the fuel you are burning, then how much pollutant it will release. So you will calculate the emission factor as well. So so this is very like comprehensive study you have to do, and for that you must have the laboratory facility. You must have a very skilled person to do this kind of work, and there should be like people should know how to manage everything. So like this is a very like there is a high demand of manpower for conducting such kind of bottom up approach. Okay, that's why we are doing the receptor based or the top down approach. So in that top down approach, we doesn't need to create that emission factor, emission inventories. We just have the data of our air pollution into the atmosphere. From that air pollution into the atmosphere, we will try to calculate from where it is coming. What is the main source of that that pollution? So this is the top down approach. So top-down approach begins by sampling air in a given area and inferring the likely pollution source by matching some common chemical and the physical characteristics between source and the air pollution sample. So this is nothing. You will go, you will collect some samples from the atmosphere using some instrument, and then you will calculate and will analyze. There may be some characteristics feature of that. For example, I gave you the example of particulate matter. So there may be some characteristics of that particulate matter. The elemental composition of that particular particulate matter in the atmosphere may match with the element composition of particulate matter from the some source. After matching, after seeing the common feature of each particulate matter from the source as well as the at the receptor, you can make some guesses. And you like there is a lot of uncertainty how you will calculate this. But yes, based on some physical and chemical characteristics of our pollutant, we can decide from where it came from. Okay, so this is the receptor based. And there are some steps by which how we can calculate this. So first we will identify the hotspot with critical pollutant level in the city or the region. For example, this one. So firstly you will see how much pollution we have in our at a one region. So first you will select the hotspot region where there is the maximum pollutant is present. Okay, then because it is the pollution present at some position, but you don't know from where it is coming. Okay, so for that, for calculation of this, you will identify the chemical composition of the particulate pollution followed by the chemical analysis of the measured sample. So first, what you do from the atmosphere, you will calculate, you will do the sampling. After that sampling, you will get to know the chemical composition of that samples. Okay, and then the description of the source impact estimate following receptor modeling. So what will you do? You know something about the source. Now you know the chemical composition of the pollutant, whatever it is in the atmosphere. You will feed such kind of information in the receptor modeling. Then these receptor models will give you the information of the apportionment of the pollution by source. So how much that different sources may contribute to whatever the exact concentration you have into the atmosphere. So this is the top down approach. Okay, so at last we can say, and whenever we are doing the chemical analysis, for example, we are doing the chemical analysis for the particulate matter. So such kind of information you can generate, like how much elemental carbon it is giving to you, how much organic matter you have within that particulate matter, how much sea salt composition you have, and you have the chemical composition of the particulate matter into the atmosphere, and you will also have the chemical composition of particulate matter near to the source. Then you can match and you can try to find out, is this particulate matter is related to that particular source or not. Because some company, for example, if it is a pharmaceutical company, that pharmaceutical company may or may not contribute to the particulate matter. This may contribute to, let's say, volatile organic compound. So whatever organic compound it is releasing, so whether the chemical characteristics of that VOC is exactly the same as we found in the atmosphere or not. So such kind of information will lead to the giving you the prediction of this, from where, like what was the source of that pollutant. Then what is the principle of receptor modeling? So how can you, like I told you, like you will feed some data into that receptor model, receptor models, and then you will go to know that. But how? What is the principle of that receptor models? This is nothing but this is based on the mass conservation. So whatever mass it was at the source, it should be at the mass at the into your atmosphere. Okay. So, Maheshwari, do you want to ask some question?
Ma'am,
Yes.
ma'am, or one help, ma'am.
Yes, yes, please ask.
Ma'am, daily class attend பண்ணாதான் வந்து ஸ்வயம் எக்ஸாம் எழுத முடியுமா மேம்? அட்டெண்டன்ஸ் வேணுமா?
Maheshwari, I can't understand the language you are speaking. Either you can speak in Hindi or English so that I can understand. I don't know. I am literally apologizing that I'm not understanding your language.
Ma'am, that ஸ்வயம் attendance.
This is about your attendance. So what do you want to ask?
ஸ்வயம் attendance is compulsory for the exam writing.
No, I don't think that attendance is compulsory.
For it is not attend in the attendance swayam online class, but also write the exam compulsory.
Writing the exam is compulsory if you want to get the certificate, but I don't think that taking such live classes is compulsory for you people. It is
The
based
live
on your interest. Yes.
The live class is not compulsory attend. It is not the problem to write the online exam.
No, no, yes, you will not face any problem if you want to attend such live classes.
How much percentage attendance, ma'am? I am like 1 month. I am attend only one online class only.
I don't think that attendance will be important for this exam. I don't think that is this is the compulsory, and I don't think that there is the attendance weightage for this kind of classes.
So the attendance is not problem to face the exam.
Yes, you will not face any kind of problem. Maheshwari.
So any class is not attending in the online, so directly go and writing the exam, ma'am.
Yes, yes, you can directly give your exam.
They in the exam center they not ask any attendance.
No, they will not ask the attendance.
Okay, ma'am. Ma'am, another one, ma'am.
Yes.
First 4 week assignment I am not submitted, ma'am. So
Uh,
fifth,
yes.
fifth and sixth assignment only I am submitted.
Okay, so I think there is some weightage for this assignment, and if you didn't like give such kind of assignment, so maybe there may be some loss of the marks. But
Ah,
try to be continue and try to finish your assignment before the deadline. So like if you didn't attempt some assignment, then leave it. What can we do now?
ma'am, that 8 assignment 5, 6, 7, 8, 9, 10, 11, 12. This assignment is enough for ma'am hereafter.
Uh, like how much correct answer you are giving to the assignment, I think based on that, it will be decide is it enough or not. Like if you are giving the correct answer every time, then it may be that there may be some compensation of whatever the assignment you didn't do. So but if you are let's say if you are giving the assignment and most of the questions are wrong, then it may be that you may or may not compensate whatever you didn't attempt right now.
Ma'am, hereafter all the question I have answered correctly means the certificate will be provided, ma'am.
Okay, Maheshwari, you will get the certificate.
Hereafter,
I don't know about this, but yes, if you are giving the correct answer, maybe you can compensate.
thank you, ma'am.
Thank you, Maheshwari.
Thank you,
Okay.
ma'am.
Thank you. Okay, we were talking about the principle of the receptor modeling. So this is the mass conservation. Whatever the mass you had in the atmosphere of that pollutant, it should be same as to the emission sources. So based on that, and then how much samples you are getting from the atmosphere, then how much species you are taking, and how much sources you are calculating from that sources. So based on that, they have given the formula. You can have a look on it. Okay, so this is the principle of the receptor modeling. There are some example as I told you now, like for the bottom up approach for the dispersion modeling, we have different type of models into the uh, scientific community. So likewise, we have a various number of receptor models. So there are some receptor models and there are some bottom up approach models or the dispersion models. So you have to tell me what are the example of the receptor approach based model. So we have multivariate model, positive matrix factorization model, Gaussian model, and the Lagrangian model. So you have to tell me the answer of this.
1 and 2, ma'am.
1 and 2. Alka gave me answer A, means 1 and 2. Of course, as we already talked about the Gaussian flow model, that was related to the bottom-up approach and the dispersion modeling. Lagrangian is also the part of this source-based models, but these two, multivariate and the positive metric factorization models, are the part of this receptor models. So answer A and B is right. Okay, so one of the model for this receptor model is chemical mass balance model. And there are some characteristics features of this model we have. So you have to tell me what characteristic feature of this model is correct. So I have this question like CMB model is most applicable to the apportionment of the primary pollutant, is most applicable to the apportionment of secondary pollutant, extensively used for the apportionment of particulate matter 10, and extensively used for the apportionment of particulate matter 2.5. So you have to tell me the characteristics feature of this chemical mass balance model. What should be the answer? A, B, C, D. This is not that much logical. This is such like this is mug up type of thing, because like this is the characteristic feature of whenever you will read about this chemical mass balance model, then only you will get the characteristics feature of this model. So like I'm not I doesn't have any expectation like you will give me the correct answer, but still you can guess something. What should be the answer? Alka gave me B answer, first and third. Okay. Alka is studying, I think. Anyway, any guesses? Okay, so answer is B, and Alka gave me what answer? Okay, Alka gave me right answer, B. So this is like this model, chemical mass balance model, is very much applicable to the apportionment of the primary pollutant. It doesn't consider the secondary pollutant, the first thing, and second is it doesn't consider the apportionment of particulate matter 2.5, but it is for the particulate matter 10 only, because it is very known and very like it has been developed 20 years ago. So and this model is only based on particulate matter 10 and for the primary pollutant. So answer is B. So you can also learn like what different models we have for the receptor modeling. We talked about the factorization model, then we talked about this CMB model, and one more model we talked about. Okay. Okay, so what are the advantages of the receptor models? So these are the advantages. It can determine if selective monitoring site or hotspot exceed compliance levels. So for example, in Delhi, if the AQI is more than 300, so you can have the hotspot region, means at that area there is a maximum pollutant, and based on that maximum pollutant you can estimate from where this pollution can come from. Okay, so you can calculate such kind of things. Then identifies critical pollutant of concern. Then it may differentiate chemical composition of the particulate matter. Then it also describes source impact estimate. It identifies source which would be most effective to control. It's just same like the advantages of our bottom-up approach. Then it also avoids the uncertainty associated with the emission inventory, because here we are not creating the emission inventory. We are just getting the data from our atmosphere, from the environment, and then we are trying to find out uh, from where this pollutant may come from. Okay, so this avoid the uncertainty that is associated with the emission inventories and the meteorological inputs that is required for the bottom up approach. And the disadvantage is the need to have and apply appropriate source profile which match emission source with the ambient air pollution. So every time you have to match the chemical characteristics of the pollutant that you have in the atmosphere to whatever the chemical composition of the pollutant that has been released from the emission source. So you have to match it somehow. In some case, not being able to differentiate sources that have the similar chemical composition, such as collinear, for example, cooking and open burning, or resuspended road dust and soil dust. So for example, this is just like that. If that emission is from cooking or from open burning, but you have pollutant into your atmosphere, but the chemical composition of that particulate matter, either it is being releasing after cooking or maybe from burning, the chemical composition is similar to each other. So how will you determine from where you are having such kind of pollutant into your atmosphere? So like this is the disadvantages of this, not being able to fully account for possible non-linearities due to chemistry and the formation of the secondary aerosol, because it is most of the time it is like uh, it is unable to tell you have secondary pollutant into your atmosphere, so from where this secondary pollutant came from, because these pollutants, secondary pollutant, are formed into the atmosphere itself. So determining the source is very difficult in such situation, but because it is not taking that much time, you don't need to create the emission inventories. So most, and whenever there is a higher pollutant into some atmosphere, you can quickly estimate from where it is coming from. So this is the advantage of having the receptor modeling, but most appropriate is bottom up approach, but bottom up approach takes a lot of time. It may take 1 year, it may take 2 years, because at each step you need the data and you want to calculate that data. So this is very huge work. Okay, so let's talk something more about the receptor models. So these models are mathematical or statistical models, means you have some equations into that model. Whenever you are feeding some input into that, that equation will solve something and will give you the output. Okay, so these are the mathematical and the statistical tool for identifying the source of the air pollutant and quantifying their absolute and relative contribution to the pollution load at the receptor location. Then it used the chemical and physical property of the gases and particles measured at the source and the receptor to both direct and quantify the presence of the source contributions. This is nothing but this is just like that. You will collect the gas, or let's say particulate matter, let's say at 1 kilometer away, you will collect the uh, gaseous sample or the particulate matter near to the emission source. Then you will see the chemical composition of these both type of samples, and then you will try to match it. Okay, and based on that you will tell whether this is coming from this side or this side or this side, and whether it is coming from that sector or that sector. So such kind of information you can get from this receptor model. This is very blurred picture, but this is the most appropriate picture by which you can just can know how this receptor model works. So firstly we have the selection of sampling site, means you will see the most polluting areas. So you will see the hotspot region. Then from that hotspot region you will collect the air samples. Then you will monitor it, so monitoring and sample collection. Then you will analyze it using different instruments. Then you will put this information to the receptor models, and this receptor model will do some kind of interpretation, and based on that it can give you the contribution of the source from where it came from. Okay, so this is the schematic diagram that is showing you how this receptor model works. This is, I think, already I have talked about. Okay, so a receptor model apportion the measured mass of an atmospheric pollutant at a given site called the receptor. So, for example, you are collecting data from 1 kilometer, and you are collecting data of the gas or the gas sample. So, from where you are calculating that sample, it is the receptor. Okay, this is the area of interest that for that area you want to calculate the source from where you had the pollution. Then the fundamental principle, as we already talked, that it is the mass conservation between emission source and the receptor. Then because we are doing the chemical analysis, so how much samples we need to have for this chemical analysis? So like how much samples you need to have, how much source you are taking, so such kind of things you have to consider. So for example, so this is just showing like the in that sample there must be the representation of the each gases or each pollutant, whatever you want to consider into your study. So larger the data matrix you have, the larger the chances that model will identify distinct factor that can identify it as a source. So you must have a huge amount of sample data set so that you can have a better estimation of the source. Okay, so you have to tell me the main characteristics feature of the receptor model. So what is the use of that receptor model, how it works? So this is based on that. So we have four options. The first is use measured concentration at the receptor. The second is refer to the chemical mass balance principle. The third is based on the solution of multilinear equations. The fourth is do not require complex meteorological and the chemical processes. So what is true about the receptor model? You have to tell me. You can guess something. A, B, C, D.
All, ma'am.
All, okay. Okay, so answer should be all. Why all? The first is it use measured concentration as the receptor. As I told you in this slide, you have some hotspot region. From that hotspot region you will collect the gas sample, and from that gas and particulate sample you will analyze the chemical characteristics of the pollutant you have at the receptor site. Okay, so the first option is related to that only. Use measure concentration at the receptor. Then it is referred to the chemical mass balance principle, as we already talked about, like this is based on the mass conservation. Then based on the solution of multilinear equation, as I told you, this is the mathematical and statistical based model, and it have a multiple linear equations. Okay, then it doesn't require complex metrology and the chemical processes as like the uh, uh, as like the bottom approach, because you know that in dispersion model we need the meteorological and the topography data. Based on that it will decide how much how this pollutant will disperse from the source to some receptor. So there is a need of meteorological data in the dispersion model, but if you are talking about the receptor model, then there is no such need. So answer should be all of the above. And in spite of that, there are some other characteristics as well. For example, it requires a low computational intensity. Then it is mainly used on particulate matters because it is easier to calculate this source emission for this particulate matter, because there is some characteristics feature of each particulate matter. The particulate matter have different elemental composition, so based on that you can find out the source. But for different gases you may not be able to find out the source. Like a very easy thing is like you can use it on particulate matter only. Then appropriate for urban and the regional scale. So these are the different and okay, so as like bottom approach, we have the steps of this, how we can conduct this study using the receptor models. So the first is the preliminary evaluation of the study area. So you will go to the receptor site and you will see what type of topography you have, what type of building you have at that place. So you will get some idea of your study area first. Then you will define a methodological framework. You must have keep in your mind what is the objective, what do you want to know. For example, if you want to know the a contribution of particulate matter only. Okay, so your objective is to identify the source of particulate matter, not of the carbon monoxide, not of the sulfur dioxide. So your methodology should be clear. You will work only for the particulate matter. Why to confuse with different gases? So your methodology must be clear. Then you will find out the site, species, and the minimum number of sample. How many samples do you need? How much species you are taking into consideration? Then what is the site? Okay, uh, uh, either like at the receptor, what type of receptor you are taking. You can't take the receptor wherever there is only one gas is coming from somewhere. You have to the site where different gases are coming. Okay, so this should be the best representative of your ambient environment. Then how you will conduct the chemical analysis. Then what is the basic statistics you will use. Then what's the preliminary data quality check. Then input data uncertainty calculation, selection of receptor model, what type of receptor model you will take into consideration based on your methodology. Then factor analysis, you will test whether your model gave you the correct information or not, and then you will report your result. So these are 11 procedures, 11 steps for conducting the source apportionment using receptor models. Okay, then okay, so the first step was the preliminary evaluation of the study area. So it means you will collect the data that is available related to the atmospheric pollution in that area. So when if by chance you have the emission inventory for that particular area, you will take it. Okay, if you have the local source profile, for example, if you have data that at that position you have that company, if at that position you have that company, if such kind of data you have, then you will collect it. Then if you have the time series data, for example, CPCB is giving you hourly data of the air pollutant, how this air pollutant is changing with the time. So if you have such kind of data set, you will also consider that data set. Then spatial distribution of the pollutant hotspot, where you have higher pollutant level, where you have the lowest pollution level. So such kind of things if you have, then you will also consider that. Meteorology at the local at synoptic scale, if you have the meteorological data, obviously you will consider. And previous source apportion study, if you have such kind of studies that has been happened for that area, then you will also collect that. And you also see the description of the physical system. For example, you will see is there any mountain or not, is there a tall building or not, because such kind of physical system will affect the transportation of your pollutant from source to receptor. So it is very important to know the geography of that area. Is there any tall building, is there any water bodies, is there any local source complexes, is there any transportation informations, or what from mostly in what direction the wind moves. So such kind of information you will collect before this receptor modeling. Okay, then here this is the time series where you are showing, you can see like with the time how different gases are increasing or decreasing. So this is the collection of the data set over time. Then first step is you have to define the methodological framework. So you must have keep in your mind what budget you have. So for example, if you have budget of only few lakhs, then according to that you have to see like particulate matter, for that analysis of particulate matter, uh, uh, 50 lakh is sufficient, and for let's say ozone estimation more amount is needed. So based on that, based on the fund you have, you will decide what type of study you want to do, what should be your objective, and then what models or software you need to buy from that budget. And for that particular objective, what should be the models. So such kind of information you must have while you will defining your methodological framework. Then species selection. So for that, this is not the species selection, this is the criteria selection actually. So in which we have three things: the site selection, the species selection, and the sample selection. For if you are selecting the reason, or let's say the receptor, so what should be your receptor area? So this will be based on like this: that site that represent a diverse range of sources in each area are preferred than those affected by the single sources. So you must have to select that receptor area in which there is a diversity of the sources. For example, there is a transportation activity going on, there is the industries, there are mining areas. So you have to select that receptor area in which there is a multiple activities are going on. Then the species selection. So how much species you want to take into consideration? So it is based on your methodology, based on your objective. If you want to see the contribution of particulate matter, then obviously you will select the particulate matter only. Why to need to worry about this carbon monoxide, or let's say different gases? So this is based on your methodology and based on your funds, based on your objective. Then the sample, how many samples you will collect. So this is the formula by which you can know how much samples you must have for a very accurate receptor modeling based outcome. So this is nothing like D is the degree of freedom. So most of the time degree of freedom is equal to number of samples minus 1, and V is the variable number, how many variables you are taking. For example, if you are taking particulate matter, carbon monoxide, nitrogen oxide, so this is like you are selecting 3 variables, then this will be 3. Then N is the number of samples, minimum number of samples, and V I already have discussed. So based on that, like if your this ratio D to V, if this ratio is greater than 100, greater than 60, then this should be the minimum. So by which you can calculate the number of samples you must have. Okay, and it is better if you have this ratio more than 100. So based on this formula, you can calculate the number of sample you must have. Okay, then okay, so this is based on this species selection. So for example, if you want to calculate from like what is the contribution of industrial areas to the species of different ions. For example, because you know that particulate matter may have different composition. Some particulate matter have the sulfate, some particulate matter have the nitrate, some particulate matter have the ammonium, and it may have the mixture of these different type of ions. Okay, so what you will do after collecting the samples, you will analyze such kind of ions, and based on some ratios you can calculate like from where it can come from. So that's why you have to see how many chemical species you must have for this receptor modelings. And then here you can see nitrate is related with particles larger than those associated with the sulfate, and ultrafine particles with gasoline and the diesel exhaust. So like based on the chemical species, based on the concentration of chemical species, you can estimate from where it can come from. Either it can come from gasoline or from diesel or from petrol. So you can have some idea about that. So that's why you have to see what type of species you want to analyze after doing the sampling from the atmosphere. Okay, so this is the question, as I already have talked about this. The minimum number of sample is the one that produce a degree of freedom to variable number V ratio, and what should be the minimum number? So this is related
Greater
to
than 60.
greater than 60. What else? Alka gave me 60. Yes, exactly. We talked about it. If our ratio is more than 60, then we have the sufficient number of samples. If it is not, then you have to increase your sample size. So this is one. Okay, let's come to the chemical analysis. So how will you conduct the chemical analysis? For example, you want to do the analysis for the particulate matter. What should be the procedure for that? What type of instrument you will use for this? Can you tell me the name of the instrument that will you use for the particulate matter? Any idea? If you want to see the chemical properties or the elemental composition of the particulate matter, so what type of instrument you will use that will give you that idea? So we mostly use two type of instrument. The one is beta attenuation. So beta attenuation is nothing but like whenever there is a radiation that is striking on that that molecule, and whenever it is reflecting back, then it will give you some information about the structure and the composition of that particulate matter. So the principle is that. So one is beta attenuation and second is TOEM. TOEM. You can see the full form of this. Like these are the two. For example, if you want to know the chemical composition of the volatile organic matter, you have the organic matter into your atmosphere and you have collected it as a sample. So what technique you will use? So you will use either HPLC. What do you mean by HPLC? Can anyone tell me the full form of this? HPLC?
Heating, air conditioning, heating,
No.
ventilation, and air conditioning.
Okay, I tell you first two word. HP means high performance. LC means?
Not getting one.
Okay, so later you will see the full form of this HPLC. So this is the chromatography technique, if you have heard about this. So like different species, different techniques you will apply. Okay, and based on that, you will do your analytical studies. Okay, so this is the chemical analysis part. Then after that, you will do some kind of statistics. For example, you will draw that box plot, you will draw the histogram plot to get the idea about your species, chemical species, and the distribution of that species. For example, you will see like at what is the maximum concentration that species has reached at. Okay, so such kind of information, like what is the mean value of that particulate matter into your atmosphere, what it may be the outlier, because after getting after doing this sampling you will get some data. Okay, so you have to know about that data, how, what's the distribution of that data. So you will apply this stat, and we can see actually I have created. So this is the box plot. So for example, if you for the particulate matter you had 50 samples. Okay, for 50 samples you have 50 values. So where these 50 values are lying, are all values are near to the median value or the mean value, or they are dispersed, like the value of the particulate matter is varying. So you have to see the distribution of your values. So this can be done by the box plot. So box plot is giving the median, the lower quartile, upper quartile, a minimum, and the maximum value. So like if you want to know the distribution of your data after sampling, then box plot is a good thing that you can plot. Then you can also plot the histograms. What like out of 50 samples, what concentration of particulate matter has the high frequency? Okay, so based on that you can also interpret something. So such kind of thing you can also calculate. Then the correlation matrix. For example, nitrogen oxide is very much related to the ozone. So is there any relation between these two chemical species or not? So such type of things you can do using this correlation matrix. Then the linear regression. Something is increasing, then another thing is increasing or decreasing. It is happening or not. Okay, and out of that 50 sample, you will have 50 value. It may be that one value is very much different from the another value. So this is outlier. We will talk about this. And based on this linear regression, you can predict about the different species based on the previous species. Okay, so this is the linear regression. Then the time series. This is showing you the minimum and maximum value and the mean value in between as a red line. So how with the time the concentration of the particulate matter is increasing or decreasing. So for the interpretation you need such kind of statistics. Okay, so based on that, I have one question. The question is, value that do not follow the distribution of data with similar characteristics are known as
Outliers.
outlier, time trend, linear regression, or correlation matrix.
Outliers.
Outlier.
Outliers.
Okay, so yes, it should be outlier. Here you can see like the one variable and second variable, they have a linear relation between them, but there may be one sample of which the value is very different, and it may be that this outlier is because of some technical error. Maybe at that time there may be some issue in your instrument, and that's why that the value is either very high or very low. So you must have to remove this outlier whenever you are interpreting this, and that's why identifying that outlier is also important for you. Okay, another will be, okay, so now after statistics, or after you have the data, let's say for the 50 samples you have 50 data. Okay, so after that list of the data, you will see there may be like whenever your machine is not working, it can give you the missing values. So out of 50 values, you may get some missing values. So how you will how will you manage that missing value? Either you have to remove it, or you can give it is the zero value. Then there may be some value that are below the detection limit. For example, if I give you one example, if there is a chromatography and there is one instrument of the chromatography, and the minimum limit that can it identify of the concentration of the organic compound, it let's say 1 gram. Okay, by chance it is, if it is giving you the concentration of organic matter less than 1 gram, that means you have some error into your instrument, because the detection limit is 1 gram. Then how can it give you the value less than 1 gram? So you have to remove that values, that value that are below the detection level. Then the signal to noise ratio, you will calculate how much signal you have, how much noise you have. Based on that you will create the noise ratio, and based on that you can remove the noise part. Then the mass closure and ion balance. If you people know that cations and anions should be equivalent. If there is any discrepancy, if these are not equivalent to each other, then you have to do something with that. Then the analysis of contingency in time and space. If something is missing, then you will try to fill it either with linear regression or with some other statistical formulation. So this is just like that. Then input data uncertainty calculation. So now you have some data, okay, and you want to feed it into some receptor model, but there may be some uncertainty. You have to calculate the uncertainty into your input data. Why? Because there is a compulsory that while feeding the data into the receptor model, you have to tell what uncertainty you have for that particular chemical species. Based on that, it will give you the output. Okay, so you also have to calculate the input data uncertainty calculation. Then you will also select the receptor model based on your objective. Based on the fund you have, you will select the receptor model. Most commonly used are CMB and PMF, and this CMB, that is chemical mass balance, this is based on the least square method. If you people know that this is related to the linear regression, and it will estimate the source contribution on the basis of the chemical fingerprint of the source and the concentration of the pollutant, as we already have discussed this. Okay, then this is not that much important. Evaluation of source contribution estimation and model performance indicators. So like whether your model is working good or not. So there are some kind of indicators, some kind of statistics that you will apply, and you will see whether your model is working well or not. Then test for model performance validation. You will see the residuals, you will see the ratio, you will see that time trend, like a lot of statistical analysis you will do to see whether your model is working or not. Okay. Then my question is, which of the following data are associated with the secondary data? So ABCD: questionnaire, continuous monitoring, field survey, published report, and articles. So what should be the right answer? There is a difference between primary data and secondary data. Nishant, what you told?
Reports or articles, ma'am.
Reports and articles. Okay. Any other guess? Alka, do you want to guess something? D maybe. Okay. Yes, answer should be D. And like we have two type of data set: primary data set and the secondary data set. So primary data set is like when you are going to the field, or when you are collecting data yourself. For example, you are conducting the poll, you are conducting the surveys, you are conducting the interview, and then you are collecting the data. So this is the primary data. And secondary data is something has published already. From that publication, you are getting data of your area of interest. So this is the secondary data set. Most of the time, whenever we are reading the research paper, so there is a in that introduction, you have the literature review. So literature review is nothing, you're referring to the different articles, and you have some like and you are comparing to each other. So this is nothing but this is the secondary data. And primary data is when you are conducting the experiment yourself, or for example, you are conducting the elections. And Delphi, I don't know about this Delphi technique, Pinnock. You can search for this. I didn't see, I ignored this. I don't know about this, but you can explore. Okay, then next question is, which of the following model follows the source-based model? So we already talked about this, right?
Gaussian Flow model.
Okay, so everyone gave me the right answer. That is Gaussian flow model. We also know like these B, C, and D are the part of the receptor-based models. Okay, the fundamental principle of receptor modeling is
Mass conservation.
mass conservation. Alka also gave me mass conservation. Yes. Okay, yes. So answer should be the mass concentration. Okay, so now receptor modeling has been completed. Now we have 30 minutes to discuss about this indoor air pollution. So let's talk about this. Here is the definition of something. So dash is defined by depiction of concentration of pollutant and the thermal condition that may negatively affect the health, comfort, and the performance of a building occupants. So
Indoor air quality.
Indoors, thick building syndrome, mechanical ventilation, hybrid ventilation. Nishant told me A. Pinnock told me B. Also should be A actually. Syndrome is some kind of disease you have. And here, if you see, it is defined as a depiction of the concentration of the pollutant. If you are talking about the concentration of pollutant, then this is something about your air quality, right? And that may negatively affect the health, comfort, and the performance of the building occupant. Means occupant, it can be dog, it can be cat, it can be plant, it can be human. So whenever some concentration of pollutant is affecting some organism within a building, then this is known as the indoor air quality. Yes, so answer should be A. Okay, so there are different contaminant sources for the indoor air quality. The first is source outside building. For example, if your home is at the Delhi, then your home may have very high concentration of different gases. So because these gases are coming from the outside. So the source is outside the building. The second can be equipment. For example, AC. So within that AC, there may be dust, there may be some microbes, and like different. For example, if it is a geyser, then surrounding that geyser, inside that geyser, there may be different type of microorganisms you have that can affect your health. So this is the part of the air pollution, indoor air pollution. So this is the equipment like refrigerator, AC, or fan. So whenever there is a dust on that, that is leading to the contamination of your inside the building. Then the human activities. If you are not cleaning your home very well, if you are smoking, smoking will come under this personal choice. If you are having the perfume spray or like home spray into your home, then this is the human activity. Because if you people know that house perfume also have have different kind of volatile organic compounds that may also lead to the indoor air pollution. Then the building component and furnishing, the wood paint or the glue that you are using to glue the some woods for the furniture. So such kind of things will come under this building component and the furnishing. Then the other sources can be, for example, by accident it is happening that contaminants are coming inside your uh, inside your home. So this is maybe the another sources. So these are the contaminant sources. Yes, here there is the example like what activity or what equipment or what furniture can give you what different pollutant, and that we can also define as the indoor air pollutant. So for example, it is if it is a painted wall, so painted wall can give you the volatile organic compound. If there is a tree or if there is a plant inside your home, then it can give you the bioaerosol. Okay, if there is a carpet in your house, that it can give you the volatile organic compound, it can give you the formaldehyde, it can give you the pesticides. Whenever there is a garage in your room or sorry in at your home, then that can give you the carbon monoxide, that can also give you the benzene. If you have switches or if you have a laptop, then that can also give you the volatile organic compound. So if you have a printer, then if you know that printer is giving a huge amount of ozone. Okay, so you have different instrument, you have different furniture in your house, and this will give you a different type of uh, air pollutant. And because this pollutant will be within your home, that's why this is known as the indoor air pollutants. Okay, so which one of the following is not the cause of indoor air pollution? Air tightness of building, indoor source of air pollution, outdoor source of air pollution, well designed air conditioning system.
Well designed air conditioning.
Well
Yes.
designed.
Yes. So we will talk about this, why air tightness of building can lead to the indoor air pollution. Why we already have talked about this indoor and outdoor source of air pollution. So if your building is not allowing gas to come in and out, then it can also give you the cause for this indoor air pollution. So exactly, if your air conditioning system is well designed, then obviously this will not the cause of the indoor air pollution. Okay, so we have different parameters that can affect the air quality, indoor air quality, and you have to tell me what are these parameters. So we have concentration of pollutant in outdoor air, rate of emission from source indoors, rate of removal of pollutant, and the indoor temperature. And options are A, B, C, D. You have to tell me. What should be the answer?
Two
Winner
and
gave
four.
me B, second and fourth. Okay, Nishant, what's your answer?
Same, ma'am. 2 and 4.
2, 1, 4.
2
Okay,
and 4. 2 and 4.
okay. Any another guess? Why not 1? I gave you the example of Delhi. For example, in the Delhi, uh, pollution is very high. Then we can estimate na ki at home we also have higher level of the pollution as comparison to the rural areas. So why not A? Concentration of pollutant in outdoor air. If there is a higher pollution in the outdoor, then obviously it may give rise to the higher pollution at the indoor as well. So A should be the right answer, and Alka gave me right answer. वैसे. Then yes, then that should be D. Then rate of emission from source indoor. We already talked about rate of removal of pollutants. So how much your building is capable to remove the pollutant, and then the indoor temperature. Mohammed, you can you want to ask some question? Raising his hand again. Anyway, so all of the above should be the correct answer. Okay, so here are the list of the parameters that can affect your indoor air quality. The first is rate of exchange of air from outdoor. So we will talk about this ventilation. What do you mean by this ventilation? So like how much, what is the rate of exchange of gases coming like from out to in and in to out? So based on that, your air quality, indoor air quality will be dependent on. Then the concentration of pollutant in outdoor air, we already talked about this. Rate of emission from source indoor, how much emission you already have inside your home. For example, you have like you are using different type of paints, and there is a huge coating of paint in inside your room. Or for example, you are every day cooking inside your home, then every time there is a emission, and that emission will be higher. So what is the rate of the emission from indoor itself? Then rate of removal of pollutant, then the indoor temperature, humidity. If you know that like the presence of volatile organic compounds or hydrocarbon, it's depend on the temperature, humidity, and even the what type of soil you have at your home. If you know that radon is a very famous as a part of this indoor air quality, because it is found naturally into the air, and this is very carcinogenic in the nature. It can cause the cancer. So based on the type of foundation, soil, and the age of the indoor structure, because with time the uh, formation of your pollutant may decrease, okay, or and also may increase. So based on the age of your indoor structure, so these are the parameters that will affect your indoor air quality. Okay, then let's talk about something about the ventilation. So ventilation have three elements: ventilation rate, then airflow direction, and then the air distribution or airflow pattern. For example, you have one room, and at that one room you have windows opposite to each other. Okay, so it means the wind is coming from the one window and going to the second window. But it may be that there are some corner where there is no such ventilation, or there may be your windows the pattern of that window installment is different. It may be like in the adjacent side you have windows, not to the opposite side. So what will happen? The airflow will be different in that condition. So you have to keep in your mind like with the position of your ventilation space, ventilation will be different. Then air distribution and the flow pattern, this is all related to how you are constructing your home. And the ventilation rate, how much space you are giving to let in or out the air pollutant. Then we have two different type of ventilation. Actually, we have three. The first is natural ventilation, the second is mechanical ventilation, and third is the hybrid. So hybrid means the mixture of natural and the mechanical. So natural means natural forces such like winds and the thermal buoyancy force due to indoor and outdoor air density difference. So if there is a density difference, if your home is cooler as comparison to the outside area, then there will be some gradient, and then warm air will come inside your cool air. Okay, and like because of the temperature gradient, because of the density gradient, so these are the natural force. Because of that, there is the exchange of gases
Can we
or the
include
exchange of particles.
pressure, ma'am? If there is a high
What?
pressure, if there is a high pressure in
Yes,
outside.
yes. Even the high pressure. If you are closing your door in such a way that you are not allowing the air in or out, but if there is any pore or any crack into your house, then there will be high pressure, like coming or out will be dependent on that. So you have to see that as well. Then there is some limitation of natural ventilation if you have in your home. For example, uh, because you don't know, like it is a fairly inefficient as it is not uniformly distributed. You are installing window, then like it may be that some corner may not have the good exchange rate of the pollutant, so this is not the uniformly distributed. Then air doesn't circulate evenly, and stale air get collected in some dead end spaces, as we already talked about. It brings pollen and another pollutant from outside air, because natural forces is allowing you to in or out the pollutant. Then we can say that it will bring every different compound that we have into the outside area to the inner area. Okay, so it can even, like if you have a house in Delhi and you have the natural ventilation, then again you may have the huge amount of pollutant indoor. Then the maximum air loss occur as no conservation of energy can be done, because it is the natural ventilation. Then if we are talking about the mechanical ventilation, then it involves use of fan and heating or the air conditioning equipments. And here, the principle of it is pulling fresh air from outside to inner spaces and exhaust stale air and the control temperature and humidity inside. So we can design our house in a such a way, and we can install the instrument in a such a way that and that the air whatever we want to have in our house will come in, and the toxic gas or the unwanted gas will come out from our home. So this is the mechanical ventilation, and this can be happened using different equipment, for example fan, for example air conditioning, for example heaters, so by which you can maintain your mechanical ventilation. Okay, so whenever you want to assess the ventilation performance, whether your building have a good performance or not, then you have to ask 4 questions to yourself. And these questions are: does the system provide sufficient ventilation rate as provided? Is the overall airflow direction in the building from clean to dirty zone? This is important. Then how efficient is the system in delivering the outdoor air to each location in the room, and how efficient is the system in removing the airborne pollutants from each location in the room? So if there is a high efficiency of removing the unwanted pollutant, then obviously the ventilation is good at your home. Then this is the best condition. If you have the mechanical ventilation with heat recovery, means you are not losing that much heat, and whatever heat you are like whatever the heat or a heat or how should I tell this? Uh, you are doing the consumption of the electricity, then how somehow you can recycle whatever the heat has been produced in your home, then this will be the best condition. And the houses that have the mechanical ventilation with the heat recovery will show the lower concentration of the indoor particulate matter, carbon dioxide, and the VOCs. Okay, so the question I have is, this is the mixture of the smoke given by burning tobacco products such as cigarettes, cigar pipes, and the smoke exhaled by smokers. So what should be done? Vinay, give me one. Okay. Alka, what do you think? What should be the answer? I think this is from previous year assignment. Okay, so Alka gave me A. Yes, the answer should be one, the second-hand smoke. So second-hand smoke is nothing but also known as the passive smoking. If one is smoking, then like this is very dangerous. The first thing is you are having the pollutant or the very toxic gas directly into your nose. Okay, after the combustion. The first thing. The second thing is the gases that has been released after combustion, this will also go into your nose. So this is very dangerous, and like there are lots of studies that are saying that more than 200 gases that has been released by the cigarette after combustion. If you are having the passive smoking, then more than that active smoker, you can have the cancer causing cancer causing cells you may have into your body. So this is the effect of the second hand smoking. And this is also the part of the indoor air smoking. If you are having smoke into your home, then it will release a lot of carcinogenic compound into your home, and this will again lead to the indoor air pollution. Okay, so whenever we are talking about the product that will cause this indoor air pollution, so we have divided into two parts. It can be the combustion products, for example, carbon monoxide, nitrogen dioxide, particulate matter, or the second-hand smoke. And it may be because of the building material or the furnishing. And this is very important because this can give you the asbestos, formaldehyde, lead, and the VOCs. So we already know about these combustion products, but I don't think you have much knowledge about the building material and furnishing. So I have some slide for this. Okay, so what is the source of asbestos? So this is the mineral fiber, and that you can have from the rock and soil. And the quality of this asbestos is that it is very high heat resistance it has. Okay, and because of that, for the insulation, for the fire retardant, we are using this into a higher quantity. And this is again a very carcinogenic again in the nature that can disturb your even the brain or the central nervous system. So exposure may occur only when the asbestos containing material is disturbed or damaged in some way to release particles and fiber into the atmosphere. The second is formaldehyde. So like everywhere you can have this formaldehyde. Either there is a glue, there is a like there are some cleaning agents. So formaldehyde you can find everywhere. So like in each and every component you may find this. This is like very huge amount of products we are using that have this formaldehyde. And this will vary according to the age of the building, since the release of the formaldehyde decrease with time, temperature and relative humidity, as we talked about this, and the air exchange rate. Then we have the VOCs. So we have list of volatile organic compound, for example, acetone. So if you talked about the nail removers, then acetone is the one of the main ingredient to that. Acetic acid, whenever you have the vinegar, so for that vinegar, acetic acid is used. Butanol, whenever you are having the combustion in the stoves, then butanol is the higher quantity that is being released. Then the carbon disulfide, ethanol, methylene chloride, and more more than thousands of VOCs that can be into your house. And it is estimated, like there is a one report by World Health Organization. It is saying that these volatile organic compounds are approximately 10 times more indoor as comparison to the outdoor. So you have to consider this, like whenever you are having the perfume, or kind of you are having the refreshing some chemicals you are spraying into your home, then this may also lead to the release of this volatile organic compounds. Then yes, I wanted to talk about this radon. So this radon is the radioactive gas that released from soil and rocks, and this is the second leading cause of lung cancer. And the geology of area can predict level of this lead in soil and water, and this is dependent on the construction site and the building materials. So, and the highest level occur in the basement, because the density of this radon is so high that, because that's why this will be very much found in the basement area and on the ground floor. So these are different indoor air pollutant we have in that may be in our home. Okay, the question is, which of the following is the source of dust mites?
Carpet.
Carpet.
Okay, yes. And what's the reason of having the dust mite on your carpet? Related to dust, right? So even if you have the hair or nails of the cat, hair and nails of the dog, even of the human body, if you have that on the carpet, then there may be dust mites. These are kind of insects that you may have on your carpet, and such carpet may also lead to the indoor air pollution. So yes, is the right answer. Okay, thank you so much. If you have any query, you can ask. Otherwise, you can leave.
जी मेरा एक क्वेश्चन थे.
हाँ बोलो अलका.
एक्चुअली एक वीक 1 पता नहीं वीक 1 है कि 2 में एक न्यूमेरिकल है. उसमें एक न्यूमेरिकल में टेबल बेस्ड है. जैसे टेबल में कोई रेंज होता है, जैसे प्रत्येक रेंज का ए और बी वैल्यू है. ए का अलग वैल्यू, बी का अलग वैल्यू, प्रत्येक रेंज का.
शायद तुम AQI की बात कर रही हो, एयर क्वालिटी इंडेक्स की, जिसमें सब इंडेक्सेस होते हैं डिफरेंट गैसेस के, और उन सब की एक लोअर वैल्यू होती है और एक अपर वैल्यू होती है.
यस सर.
ओके, हाँ बोलो आगे उसका.
तो उसमें ए और बी की वैल्यू लर्न करने पड़ेंगे प्रत्येक रेंज के, या फिर गिवन रहेगा क्वेश्चन में?
वो गिवन हो जाएगा. वो मोस्टली टेबल को लर्न नहीं करना पड़ता. बाय चांस उसका क्वेश्चन दे रहे हैं तो तुम्हें वो लोअर एंड हायर वैल्यू उस कंसंट्रेशन का देंगे. बट हाँ, लाइक कंसंट्रेशन का देंगे, लेकिन क्योंकि दो चीज पे डिपेंड करता है. फॉर एग्जांपल, आप कार्बन मोनोऑक्साइड से AQI निकालना चाहते हो, सो तुम्हें दो चीज चाहिए. दो ही चीज चाहिए, एक लोअर और हायर वैल्यू, और एक उस पर्टिकुलर पॉल्यूटेंट का कंसंट्रेशन. सो तुम्हें ये तीनों वैल्यू तुम्हें देंगे, और उसके बाद तुम्हें उसका मैक्सिमम वैल्यू निकालना होगा. मैक्सिमम वैल्यू से तुम AQI कैलकुलेट कर सकते हो. गिवन होगा उनका वो. Any another question or suggestion or query? Okay, then you can leave, and okay, bye. We will have the lecture next week from 6 to 8 on the same time. Okay, see you then.
Thank you, ma'am.
Thank you, Isha.
Thank you, ma'am.
Thank you, Pina.